Sit down and shut up. We're doing notes. Is that good? Is that it? That's too bossy. We'll try different things. Yes. That's why I said sit down and shut up, because I knew it was recording. Do the remix on it. Do you know how long it takes to edit videos when you're doing all that stuff? I don't have that kind of time. I don't do that. Okay. So, confidence intervals. So this is section 10.1. Confidence intervals. All right, so we use a sample, and we'd like a simple random sample or something as good as a simple random sample. From our population. To estimate information about our population. TION, there we go. And that information about our population may be, what percent is going to vote for something. It may be an average of something. It may be a standard deviation. We're mostly going to do maybe a slope of a regression line. For right now, we're going to be basically estimating proportions and means. But we can do other things. All of this information that we're going to estimate about our population, these are all called parameters. Okay, so we're going to try to estimate a population parameter by going out and getting a random sample. Okay, we're going to use the sampling distribution for our reasoning, for our logic. Of what we're saying here with these confidence intervals. So, the sampling distribution. We know something about the sampling distributions. And one thing we know about the sampling distribution may be the shape. What's the shape of a sampling distribution? Approximately normal. But that only happens when? If it says the population is normally distributed, or if n's greater than 35, or if n times p and n times 1 minus p, when we're doing proportions, are greater than 10. So our shape is approximately normal when, and I'm going to say ... because we'll have all these things that we'll end up checking. What's the center of our sampling distribution, whether it's normal or not? It's the mean of the population. So I'll say the center of our sampling distribution, mu sub x, is the population mean. Or if we're dealing with a proportion, the mean of the sampling distribution is the population proportion. Okay? And then, of course, we can describe the spread. And the spread, can one of you guys get the door, please? The spread of the sampling distribution, if we're dealing with means, standard deviation of the population. Oops, let me go back here. So the spread, we'll call that the standard deviation of the sampling distribution. It's the standard deviation of the population divided by the square root of n. Or if we're dealing with a proportion, and take the square root of all that. Okay, so we can describe the sampling distribution pretty well. Okay, now here's where the logic of the sampling distribution comes in. Your sampling distribution contains all possible samples. You know, it's got samples out the yin yang. It's got millions and millions of samples. Billions of samples, because it's just theoretical, so it's got a bunch. Okay? So there's my sampling distribution with a whole bunch of samples to it, but I only get one of them. I only get one. Now, I'm going to estimate the center of my population. I'm going to estimate the mean of my population from that one little sample. Okay? If this sample that we get is near the center, of the sampling distribution, then I'm going to make a pretty good report on what I think the population parameter, population mean, is going to be. So we'll make a good reporting of that parameter. But maybe I happen to pick one of these samples way out here. If the sample I get is not near the center of the sampling distribution, I am going to make a false report. Not near center. Okay, so here's what I try to do to protect myself. I give myself some wiggle room, because as a statistician, I don't want to be making false reports about what this population is, because that can, that can end up being lawsuits and whatever, and just bad mathematics. So I create an interval. So we're going to create an interval around the sample mean and we'll say that the population parameter or mean should be within a specific interval. Okay, so what I'm going to do for that to make that interval is I'm going to make it 2 standard deviations. We'll start off with 2 standard deviations